This lesson is Unit 1, Section 2, Solving Systems with Matrices. So the first thing we're going to talk about is how to solve a matrix equation. And a matrix equation will be formed A times X equals B. So a matrix named A times a matrix named X equals a matrix named B. So our first step is we're going to find the inverse of the first matrix, A. Then we're going to multiply both sides of the equation by the inverse on the left. So that means we're going to have something that looks like this. The inverse of A, oops, forgot the law, oops. Let's start that over. All right, so the inverse of A times X equals the inverse of A times B. So what should happen is when you multiply a matrix by its inverse, we're going to get the identity matrix. So it's going to be left with IX on the left side, so it's really just X. On the right side of the equation, we're actually going to multiply the inverse of A by B, and the result is our answer. So this is our example. This is AX equals B. So our first step is we're going to find the inverse of A. So if you recall, the inverse is found by doing 1 over the determinant. So that's going to be negative 6 minus positive 2. Right, so we get negative 8. Then we're going to multiply that by switch the down diagonal, change signs of the up diagonal. And then let's distribute. So this is going to become negative 3/8. This is going to become negative 2/8, or negative 1/4. This is going to become negative 1/8. And this is going to become positive 2/8, or positive 1/4. If you're more comfortable with decimals, since these do round nicely, you can do that. So if you chose to, this could be negative 0.375, negative 0.25, negative 0.125, and positive 0.25. So if you feel more comfortable with decimals, as long as they round nicely, you can convert them. But now we're going to take the inverse of A. I'm not going to have to show my work by multiplying it on this side, so all I really have to do is inverse of A times B. So we're going to take this matrix I just made. Let's just rewrite it. And we're going to multiply it by matrix B. So if you recall, when we're multiplying, rows in the first, columns in the second, so we're going to have negative 3/8 times negative 34 plus negative 1/4 times 7. Then I'm going to have negative 1/8 times negative 34 plus 1/4 times 7. All right. If you do this on a calculator, you might get a fraction, you might get a decimal. So I'm going to actually write them as decimals right now. I know we're mixing ways right now, but that's okay. So negative 3/8 times negative 34 gives me 12 3/4, or 12.75. Plus negative 1/4 times 7 is negative 7/4, or negative 1 3/4. So that's minus 1.75. Negative 1/8 times negative 34 is going to give me 4 1/4, or 4.25. And now positive 1/4 times 7 is going to give me plus 1.75. So my final answer, 12.75 minus 1.75, and then 4.25 plus 1.75. So my answer is 11/6. So x, matrix x, equals 11 over, well, not over 6, 11 and 6. We'll do another one together. This one is written, instead of having a variable as a matrix, the matrix is made of variables. So all that means is at the end, if it had been this problem, x would be 11, y would be 6. So we're going to do the same thing we just did last time. I'm going to find the inverse of the first one. So we know that 0 minus negative 8, so 0 plus 8. So that's 1 over 8. Switch the downward. Change signs of the upward. And then distribute. Again, if you feel more comfortable with decimals, that's okay. So now we're going to take this matrix and multiply it by our B matrix. All right, so circle the rows in the first, columns in the second. So that's going to be 0 times 16 plus negative 1/4 times negative 36, and 1/2 times 16 plus 1/4 times negative 36. So simplifying, 0 times 16, we get 0. Negative 1/4 times negative 36, we get plus 9. Then we get 1/2 of 16 is 8. Plus 1/4 times negative 36 is negative 9. So 0 plus 9 gives us 9. 8 minus 9 gives us negative 1. So what that tells me is technically x equals 9 and y equals negative 1, because x was the first part, right? X was the top number, y was the bottom number. I'm okay with you leaving your answer as this, but if I asked you what is x, what is y, you should be able to tell me that as well. So you go ahead, give this a try, pause it to see the answer. All right, so you should have gotten x is 5 and y is 3. The reason we do this is because we can solve a system of equations using matrices. So we're going to make a matrix equation of our own. A is the coefficient matrix. So we're going to take the coefficients of the x values and the coefficients of the y values and create a matrix out of them. The second matrix is our variable matrix. So whatever the variables were in the problem, those are going to be the 2 that go, or 3, or however many that go in the variable matrix. And then B is the solution matrix. All right, so whatever was on the other side of the equal sign is going to go into that last matrix. And then we're just going to solve the matrix equation. So let's create the system, create the matrix equation out of the system of equations, and then we're going to solve it. So I'm going to start with my coefficient matrix. Negative 2 and negative 5 were my first equation. That was x and then y. So I'm going to make sure I keep it the same. X and then y. That's going to be 3 and positive 2. My variable matrix, I was using x's and y's. So my variable matrix is xy equals my solution matrix, negative 19 and positive 1. So now this looks just like the matrix equations we were solving. We're going to go ahead and solve it the same way we did. So we're going to start by finding the inverse. So that's negative 4 minus negative 15, so plus 15, so that's 11. Switch spots. Positive 2 up here now, negative 2 down here now. Change signs. Negative 3 there, positive 5 there. And then we're going to distribute. We're going to leave these all over 11. It's just going to make our lives easier. All right, definitely don't want to turn these into decimals. They're going to give us a headache if we try to do that. So now we're going to take this and we're going to multiply it by our negative 19 and 1. Just trying to save a little space here as we're doing this. So it's going to be rows by column. So that's 2/11 times negative 19 plus 5/11 times 1. And then it's negative 3/11 times negative 19 plus negative 2/11 times 1. So we're going to have some improper fractions here. That's okay. It's all going to work out in the end. This becomes negative 38 over 11 plus 5 over 11. This is going to become 57 over 11 minus 2 over 11. So that's really negative 33 over 11. And that's really 55 over 11. And now you could see 11 goes into both of those evenly. So our answer is really negative 3, 5. So the system of equations is x is negative 3, y is 5. You could always check your answer when you're done. Plug negative 3 for the x's, plug 5 in for the y's, and you should get 2 true equations. So you could try this last one, pause it, and then I'll show the answer. All right, first we have the matrix equation. And then if we go and fully solve it, our answer matrix would be negative 4, negative 5. And that is using matrices to solve systems of equations.